It's really easy to check the reasonableness of points being solutions to linear and quadratic systems algebraically. The point given needs to satisfy both mathematical statements. It needs to make both of these equations true. So let's test the point in both equations. We've got 2x minus y equals negative 3. And our quadratic equation 2x squared plus 5y squared plus 46x plus 2y minus 51 equals 0. And we want to know, is this point here a solution? So we're going to test that in both of our equations that are given. We substitute the 0 for x, the 2 for y in each equation, and that results in 2 times 0 minus 2, and is that equal to negative 3? So 0 minus 2, is it equal to negative 3? Negative 2 is not equal to negative 3. So we already know that this isn't going to be a solution. This is not a solution. Right? 0, 2 is not a solution. And to verify that, we could check it in the other one, but even if it did equal 0 on this whole side, if we substitute 0 in for x, so 0 would be here, and then we would substitute 2 and 2 in here, and that still would not equal 0, so this is not going to be a solution. So that's all you have to do for checking solutions. We can do one more example together. So let's look at number 3. Let's look at number 3. And we're going to test the point 1, 3, x and y into both equations. So negative x plus y equals 0, and 2x squared minus 6y squared plus 6x minus 3y minus 31 equals 0. And both of these statements have to be true when we substitute the point in. So we've got negative 1, let's do that in a different color. Negative 1 plus 3 equals 0. Negative 1 plus 3, do these equal 0? And 2 does not equal 0. So this is not going to be a solution. Not a solution. And so both times you've gotten out of having to test it in the quadratic equation, but that will not be true for some of these other ones. So you continue substituting in the points for x and y. We've got, let's see what would happen if we put 1, this would be 2, and if we put 3 in here, that would be 9. 9 times 6 is negative 54. And then we would have plus 6 minus 9. And then we'd have minus 31. Would that be equal to 0? So that would be up to you to figure out after substituting these values in for x and y into each of your quadratic linear systems.